Leetcode problem. So the problem name is fruits into baskets. Part 3. We are given two arrays of integers, fruits and baskets, each of length n, where fruits of I represents the quantity of the ith type of fruit, and baskets of j represents the capacity of the jth basket. From left to right, place the fruits according to these rules. Each fruit type must be placed in the leftmost available basket with a capacity greater than or equal to the quantity of that fruit type. Each basket can hold only one type of fruit. If a fruit cannot be placed in any basket, it remains unplaced. Return the number of fruit types that remain unplaced after all possible allocations are made. So if you'll check the constraints, like this is uh, quite high, so we can't do n square thing that we did for part 2, but we can still solve this problem using segment trees basically. So what we will do is prepare a max segment tree over baskets array, right? So the max would look something like 3, 5 and 5. So where basically this prefix max, right? So p pr underscore max of ith represents the max in range uh, 0 to I, right, in baskets. Then it's quite easy to figure out the allocations, because we'll just loop over this fruits array. Then the first number is 4. Then what we need to do is we need to find the first index in this prefix max in the range 0 to n minus 1, where n is the length, right, where basket's capacity is greater than or equals to 4. So here the first element where this happens is this. So we'll allocate this fruit to this basket, and we'll update the value at this index to be 0, so the new prefix max would look something like this. Then we go to 2. Then we find the first index where uh, the basket's capacity is greater than or equals to 2, right, which is 0. So we'll update this to 0 so that it can't be reused, and the new prefix max would look something like this. Then comes 5, but sorry, this will change to 4 now, right, because this was changed earlier. So now we need to find a basket where capacity is greater than or equals to 5, right, but we don't have any such basket. So we this last fruit will remain unplaced and we'll return 1. So, and the first basket where capacity is greater than or equals to the fruits quantity, right, we can find that using binary search, because it's a very classical problem, right? So because and binary search will work because every index after the so the like for each index, if we stated that this array's value represents whether that value is greater than or equals to the current fruits quantity, that will look something like this. And then after true appears, then it will keep on appearing, right, true, because if something in the middle here is giving true, right, it it's then after that, whatever elements are there, because this appears before them, then the maximum will still be greater and still give true, right, than for the particular fruits quantity. So that's the concept we'll use, right? So let's code this approach up, and for segment tree let's copy some random Google implementation because the AI now is quite smart. So let's try to paste this, right? And let's initialize the segment tree. So let's copy the class name and we'll pass, and let's reduce these names to F and B, right? And let n is equals to length of fruits, and we'll pass baskets into the segment tree, right? Initialization. And then what we will do is we'll loop, or we'll prepare a result variable and we'll return this in the end, right? Before that we'll loop over range n, so from 0 to n minus 1. So first thing that we can do is we'll say if seg dot query in range 0 to n minus 1, right? If this itself is less than what's the fruit capacity is, current fruit's capacity is, then we can't find any pairing because in the whole range the maximum is lesser, so there's no element in the baskets array whose capacity is greater than the current fruit's quantity. So we can just say result plus equals to 1 because we found one unplaced fruit type, and we can just continue. Now the other case is we can find the answer, and we'll find the answer using binary search. So let the left variable equals to 0, right variable equals to n minus 1, and then we'll say index is equals to minus 1. Index is where we'll store the index where the first time true, like the condition of the capacity being greater than the current fruit's quantity, that happens. So while L is less than or equals to R, what we'll do is we'll calculate mid, which will be equals to this, and we'll say that if seg dot query 0 to mid, right? If this is if this is greater than or equals to the current fruit's capacity, then this can work, right? But we still gotta check the left hand side. So we'll say index is equals to mid, and we'll say right is equals to mid minus 1, right? Otherwise we can just check the we can just update the left side so that we check the right half. So we'll do mid plus 1, and once we have broken out we can say if index is not equals to minus 1, what we can do is we can say seg dot update whatever that index is to 0 so that it can't be reused. And right, so let's try to run this code now. Okay, I think this should be self.m. um, yeah, so as you can see the sample test cases are passing, right? So let's submit the solution. As you can see, we have passed all the test cases. So thanks for watching.